Maybe there's something wrong, right? When maybe they are not update the so some operator and these things, right? No problem. Don't worry about that. We can try to use your own e-views. So now, we try, once it's successful, for example, to produce a result, right? Because just now I create the, like for example, even though I give it the investment as a dependent variables, I click on the CAPBL, I open them as a, what we say, the group. Then I go to view, then I go to correlation test. If I click on the panel correlation test, so you will pull up this framework. After this, you also can go to the quick here. Then in the group as statistic, you can click on this Johansson test. Right? Then you also pull up this option. So under here you have three again, petronical and fission. So again, the intercept, no trend. So refer to the alpha and also your delta in your test equation. So you assume, it means that you test whether there's a correlation with the intercept or trend or not. Then you click on this one. Because of this petronic, there's a non-parametric approach. So there's a spectral estimation. And when you scroll down here, only you will use this method. Then you will just automatic the selection for the band one. Then you click on OK. So once you click on OK, you will pull up this 11 statistic. So the X statistic is under this alternative is homogeneous, right? Homogeneous, the rule for the as alternative less than 1. So out of this name, how many are significant? So you can refer to the p-value here, right? P-value here. So how about different here? Investment CAPBL. Let me check. Investment CAPBL 1935, 1954. Okay, 200 and then 10. SIC. So this is also different, yeah? Oh, yeah. This because I checked is based on this no intercept, no trade, right? This third test auxiliary regression. These are the third test equation. So this refers to number 3. So no alpha, no delta. That's why it's a different behind statistic here. So is there any correlation? Yes, based on this first 8 statistic, actually all statistics actually reject the Hirschsprung. Because of p-value significant, right? Reject the Hirschsprung significant at least 10%. So for example, this one significant at 10%, and then these two significant at 10%, remaining significant at least 5%. So all of these statistics actually reject the no correlation. So they support the p less than 1, right? P less than 1. Then how about the remaining these 3 group statistics? So for these 3 group statistics, so we still reject the no correlation as a Hirschsprung. So it means that there is a co-integration in the long run, and the rho I is less than 1 as alternative, rho I. So this is actually heterogeneous, so the rho I is less than 1. So at least these 2 out 3, right? 2 out 3. So majority shows that there is a significance, means a correlation in the long run. There is a correlation in the long run. So how about statistic which consistent with the lecture notes? We go to the correlation test and then check for the box intercept and no trend, right? Yeah. So no trend on it. So no trend, but with the intercept. The first case to check whether there is a correlation with a intercept or not. That's based on SIC and based on US automatic for the non-parametric equation. So here, so these 3, yeah, consistent. So these 3, 4 is not significant at all. So out of this 8, 4 is significant. Only 4 significant. 1, 2, 3, 4. So So this unweighted, this weighted, right? So out of this 8, only 4, 50%. So still contributed, right? Yeah. Still configuration acid for these 3 variables. So there is a configuration acid for these 3 variables. And against 2 out of 3 have P1, PI actually less than 1. So not only that, right? You also can see the individual result. You also can see the individual result because once you scroll down, you can see the augmented decay flow result because this one is actually based on the angle pressure, right? Angle pressure to solve the zero correlation, this residual based configuration test. So you can see the individual AR terms. And also together with the previous parameter, these are non-parametric things. And that's why you can choose based on the bandwidth. And the augmented decay flow is choose the backlight with the maximum length for all these 3 cross sections. This is for our 10 films here, 10 US film here. So now, so that's the things like, okay. So how about another test? See whether there is a correlated in the long run with the intercept and also train or not. So you can go to the correlation test and then choose the intercept and train. Okay. So again, similar with our previous result, still 50%, right? Out of this 8 statistics shows that there is a correlated in the long run, and 2 out of 3, right? Support the between means that between dimension means that the rho I is less than 1 for all the 10 something like for all the 10 cross section. So how we going? What's the details here? So the top portion actually the type of the test, the original, and also the exogenous variable. Is it true? Yeah, because it refers to the patronic and then the variables and also sample and also how many cross section and also your null hypothesis. There's no configuration, right? As a original for the patronic test. So remember that what is the original? No configuration in the long run. Then this one is a patronic test statistic, which against alternative either homogeneous or heterogeneous alternative. This refers to the within and this refers to the between. So what is the difference? This homogeneous, right, is the rho is less than 1. It is a common AR. But this one is an individual AR. So autoregressive. So this one actually refers to the common one, right? Common coefficient. Actually refers to the P equals to PI is less than 1. Right? So refer to this. Yeah, this one. This common, right? But still same. But this one is individual PI less than 1. Of heterogeneous as an alternative. That's why I call between. Individual AR. So why they want to bring up this issue, right? Because different because you have 10 cross section, right? So the issue in the panel analysis is what should include in your panel. So remember our discussion is one of the challenging part in the panel analysis is should I pull this 10 film into one panel? Right, should I pull this 10? This is just a 10 film, right? How about we have 100 film? We have 200 film. So which film should be excluded out? Which film should be included in? So that's a challenging part here. That's why in the panel unit test we talk about the cross-section dependence. Because the respective film has their own characteristic. We should not include them together, right? So we're going to discuss this challenging part in the last lecture to talk about the issue in this panel analysis. So now, so what we can do the conclusion. So 5 out of 11 reject the null of no configuration at 5%, at 5%. So based on this, we want to test for the test equation configured by including the just intercept. What we conclude that is how many? 5. Yeah, 1, 2, 3, 4, 5, 6, 6, right? Don't know why here put 5. So because it's 1, 2, if say 5%, so this one not included, right? So 1, 2, 3, 4, 5. So 5 out of 11 shows that there is conjugated in the number, okay, at 5% significant levels. So this is our conclusion. So again, you can look at their individual if you want to check the rule, right? So these are the individual items. So it's not about the auxiliary cross-sectional result. So you can show in the intermediate calculator if you want to use this information. Are you okay? Still struggling with your English 13, right? Because I think that when they install the English 13, maybe they not update the recent operation yet. So I think you need to probably say update the English 13 by your own, right? Maybe you click on this one window, right? Or maybe option here, auto update, maybe you can solve the problems, right? So okay, so now we move to the second one. The second one is a gown. So these are also based on the engine gradient-based qualification test. So what is the difference here? So the gown follow the same basic approach like the electronic, but specific the cross-section specific intercept and homogeneous coefficient on the first stage regression. Yeah, then this gown try to modify that because this one is 9 right? How about the electronic? Electronic is earlier than electronic. Electronic somewhere in 1999 also, 2004. So both also come in the same years, right? 1999 also. So let's see how the gown work, right? So this gown follow the same basic approach like the electronic, but he bring out the cross-section specific intercept. So just like the ones to individual firms like for our case, individual firms will have their individual intercept, right? But homogeneous coefficient. Homogeneous coefficient on the first dash regression. So let's see how it works. So again, we come up with your variable y and also x, and individual intercept, right? So you can see your alpha become I, subscript I. So how about the previous one? Let me check. The previous test don't have, right? Don't have the. Here still have alpha, right? Yeah, but we assume heterogeneous intercept also. So where is the difference here? So let's see what is the idea behind gown. So you have an equation number 4, and the first stage, right? So you assume these two is followed by y equals to the y it minus 1 and x equals to x it minus 1, and require the alpha I to be heterogeneous, but this one is homogeneous. So they are same. So homogeneous slope coefficient. So homogeneous across the cross section. So this one try to modify the electronic test equation. So this one allowed to be hetero, but the coefficient for this slope, it means that slope coefficient assumed to be homo. So pull the slope coefficient same, and setting all the train coefficient to be 0. So this is under the gown. So what is the gown do? So the gown runs either the pull auxiliary regression. So auxiliary regression, so the residual against on the leg for the residual in a panel setting, and test the rule here. So these equations, this residual, right? And also the augmented version, so against you have the changes for the leg for this residual. So what is the push now? No configuration. So, and this girl, right, they have a 1, 2, 3, 4. Yeah, 4 statistics. So, let me see. So you will come up with like this, like you come up with an ADF. We come up with an ADF and then, okay. So following the statistic like the Dickey-Fuller for the P, Dickey-Fuller for the subscript T and the P star, and the T star here. So for the root greater than 0, then you have so this one just want to excuse based on the idea that they will produce you the one statistic, and then to show that whether there is conjugated or not. So under the rationale, no configuration. So again, you need to choose the newly best. Means that also involve the non-parametric, right? Non-parametric. So now let's see. So you can go to the view here, and then go to configuration, and you choose the panel configuration here. Then you choose the second option, the gown angel granger face. Then only individual intersect. Because under the gown, it's not allowed to put into to test the correlated with the trend or not, or no trend. That's why you see there is a statement here. I'm setting all the trend coefficient to 0. So this is a different compared to the Petroni. Petroni allow for 3 different test equation, right? Intersect the trend and then intersect as well as no trend or intersect. But this one just the individual intersect. So other than that is a red line. You still remember it's an angle brancher, so we have to choose the appropriate line. So based on SIC and then maximum line, based on maximum line and then choose the appropriate line. And this is the spectra based on new line. Then you click OK. So once you click OK, you can take a look the test equation. This so the big difference, right, compared to the Petroni, because Petroni proposed that there are 11 test statistics, but Gao is based on this augmented version, the difference for the residual, and then runs on the lag for the residual, and also the residual lag for the residual here. So this is the test equation. This is a test equation that we study in the time series, but this is under the panel settings, right? Then based on this test statistic, again they compute that the count residual in the test statistic. So the big difference is no longer from here, is that because they're based on the one test statistic, and they come up with the count configuration test. So here, significant at 10%. So what you can conclude from the result here? So what you can conclude? So reject the rationale of no configuration in the long run. No, reject that, because if you believe that there is a 10%, so there is no configuration in the long run by using 10% significant values. Then how about 5%? If you based on 5%, right, then there is no configuration. If you base on 5%, there is configuration, right? So there is configuration. So there is a difference here. So what else you can study, right? Later on, we are going to discuss about this Johansson configuration test together with the single equation. So what else? Actually, in the image, right, we also got the causality as well. So before we move to the second part, what else? Yeah. Configuration and long-run covariance. If you click on this test tag number 3, right, it's a feature. It's a feature, then you can, these are the things we're going to discuss after the break time. So, by the way, right, so normally we just deal with the single equation approach, right? Yeah, Petroni, and then the Gao, actually it's a single equation approach. So after the break, we're going to deal with the, like the Johansson type. So the difference between this Gao, Petroni, and also this Fisher Johansson. So just like the Angel Granger is based on single equation to study about the configuration. But for the Johansson, it's based on the multivariate, right, multivariate approach. And but this one is combined with the in a system. It's different compared to the Gao and also the Petroni type. So okay. So let's see the paper I uploaded in the spectrum, right? Take a look. So have you go through the papers I uploaded the spectrum actually? No, right? Just look at the lecture slide. So, for example, you can study this one in published in 2015. So this one is talking about the panel configuration and also the causality. So when you scroll down, right, you can take a look how people report the result, right? Report the result and what is the motivation, and so on. So they discuss about the configuration test, configuration test, like how they discuss about the patroni, right? Patroni test, panel configuration, like there is a patroni test. So this patroni test is is derived the 7 panel, and then with the for example, he rewrite this equation with the dependence and also independence variables, and also with the intersect and with the time train, right? So with the either is a fixed specific firm specific fixed effect, and also the time train trainer. So just now, like if you say want to test for the correlation with no train and no intersect, so you just go back to the model without the intersect and the trains. So it depends on how you test your configuration, and the estimated residual which duration for the long run relationship, I have to test for this one. Because once you estimate the models, then actually is referred to this residual, right? And testing the residual here, testing the rule whether equals to 1 or less than 1. So here we have a homogeneous as an alternative or heterogeneous as an alternative. So I have either is a homogeneous panel or heterogeneous group, right? It means homogeneous or heterogeneous. So because it's a single equation, right? So single equation. So if you want to study about the configuration, right? So how you going to study the configuration test? So like see here, you want to touch on this one. So maybe we take a break, then we come back here to talk about the Johansson and also the configuration test. So by the way, you can spend some time to go through the journal articles here at the Outlook is 2007. Right? So you can take a look how people to bring out the panel integration approach. People will just test the panel unit test, right? Test the panel unit test for all the variables. Then they will run the panel configuration test, like report all the 4 plus 3 is 7, right? 7 test statistics here. It means they just report the 7 statistics, but not the weighted one. So it shows that all the variables actually configured in the long run based on these 7 statistics. So then, I think this paper, right, averages that divide the sample. This paper that divide the OECD country as a panel and a non-OECD, right? So OECD, non-OECD, as well as all the countries. So they have because they believe that there should have a different perspective from the OECD and also from the non-OECD, as well as in the aggregate level. So they have 3 different panel, and then they also report the panel dynamic OS. So actually, after you run the configuration, right, you can report the because if we not talk on this panel unit rule, I think in the initial panel analysis, we straight away go into the random effect, fixed effect, right, and also pool OS. So if let's say we found that the variable actually I1, then you also found that there is a configured in the long run. So the fixed effect, random effect, as well as the pool OS no longer valid. So in that particular scenario, we have to use that regression that accommodate the I1 variables. So in this field, so either researcher will use the fully modified OS or the dynamic OS, which normally used to tackle the I1 series. So you can see this researcher used the dynamic OS to report the coefficient. By using the different proxy for the dependence variables. So the dependent variable is Y, right? But they use different proxy for the dependent variable together with the independence variables based on the dynamic OS. Because they found I1, so they proceed with the correlation test, and then they found there is a correlated, so they proceed with the approach that handle the I1 series. So they report the dynamic OS, right? And then they will report the panel causality to study whether the for these three different groups, OECD, non-OECD, as well as all the country. So the direction is from the DF go to the D1 or the other way around, right? Or they have a bi-directional. So based on the panel causality test. So we have to be cautious lah. Even though our series is I naught, right? We still can run the panel causality. If the series I naught, we just proceed with the conventional, means that study the causality in a level form. If there is the I1 series, then we have the first difference here. So there is another idea behind the panel causality that handle the I1 series. We have the first difference